In this problem, you are dealt one card from a standard 52 card deck. We're asked to find the probability of being dealt the following. So I'm not going to write out the sample space for all 52 cards because that seems like kind of a waste of my time. I have that on the previous page. But I will note that n of s is going to be 52. There's 52 ways we could pick a card out of the deck. Now the probability of drawing a queen, first I want to talk about the event and the number of the events we could get a queen. There are 4 different ways we could get a queen. The queen of diamonds, the queen of hearts, the queen of spades, and the queen of clubs. So when I'm asking for the probability of pulling a queen, I'm going to take the number of ways I could pull a queen, divide that by the number of ways we could pull a card out of our sample space S, and that's going to be 4 out of 52, which reduces to 1/13. So the probability of pulling a queen is 1/13. Next, we're looking for the probability of drawing a heart. So if you look back at that other page, how many different ways could we pull a heart? Well, there are 13 different hearts, A through 10 and Jack, Queen, King. That's 13 different heart cards. So the probability of pulling a heart is the number of ways we could pull a heart divided by the number in the sample space. So that's 13 out of 52, which reduces to 1/4. Next, we're trying to find the probability of drawing the ace of spades. So when I'm talking about ace of spades, there is only one card in the entire deck that is the ace of spades. Every card in the 52 card deck is unique, so the ace of spades there's only one. So the probability of pulling the ace of spades, I wrote spaces before, the ace of spades is equal to the number of ways we could pull ace of spades divided by the number of our sample space, so that's 1 out of 52. And the probability of drawing a card greater than 3 and less than 7. So this one, we're talking about something greater than 3, that's 4s are greater than 3, 5s are greater than 3, 6s are greater than 3, and these are also less than 7. If I go any higher, then that's equal to 7, and that doesn't count. If I go any lower, then that's equal to 3, and that doesn't count. And aces, king, queen, and jacks, they're not less than or greater than numbers, so these are the only 3 numbers I'm talking about, 6, 4, 5, and 6. So how many different ways could we pull a number greater than 3 and less than 7? So I'm going to use E for this, okay, because that seems like too much writing. So how many different ways? Well, you have a 4 in hearts, diamonds, clubs, and spades. Then you have a 5 in all 4 suits, and then you have a 6 in all 4 suits. So that's actually 12 different ways because each of the 4, 5, and 6 appears in each suit. So the probability of this event is going to be the number of the event divided by the number of the sample space. So we're talking about 12 over 52, and 12 over 52 can divide by 4. So if I reduce the top by 4, you get 3, reduce the bottom by 4, you get 13, and that is the probability that we're going to get a number greater than 3 and less than 7. Now we're going to do another problem about children in a family. So let's say you select a family of 3 children. If M represents male and F represents female, the set of equally likely outcomes for the children's genders are, notice that we have 3 kids, so each sample space has 3 letters in it, MMM, MMF, and so on and so forth. So I can tell you right now that the number of ways and that we could get our sample space, we have 1, 2, 3, 4, 5, 6, 7. There's 8 different choices of the way you can have 3 sets, a family of 3. So now I'm going to find the probability of having exactly one female. So when I look up here, I'm trying to find the families with only one female. So MMF has just one female. MFM has one female. MFF doesn't. That's two females, and we're talking about exactly one female. And then FMM. And that's it. All of the other ones have either more females than one or less. So we have 3. So the probability of having one female is going to be n of one female divided by n of s. So there's 3 different ways out of a total 8 that we could have exactly one female. I'm going to go ahead and erase those highlight marks. Next, we're looking for the probability of having at least one male. Now, at least, that's different. When we're talking about exactly, then you have to have only one exactly. But now that we're having at least, that means one male or 2 males or 3 males. So how many could have 1, 2, or 3 males? Well, this first one, this one, this one. All of these have at least one male except the last one, which has just 3 females. So when I'm trying to find this problem, when I have the number of ways we could have at least one, and I'm just going to use m, is going to be 7. So the probability of at least one male is going to be 7 out of 8. Our next problem says, what's the probability of having 4 male children? Now, looking at our sample space, each one of these has only 3 children, and that's because that's what was given in our direction. So how many different ways could we have 4 males? Well, none, because there's only 3 children in this problem. So we have the probability of 4 males is going to be 0 out of 8, which reduces to just 0. There is no way of getting 4 males if you only select from a family of 3. And then our last example, we have the probability of having fewer than 4 female children. So if I look up in my problem, fewer than 4 female is 0, 1, 2, or 3 female children. So this one has 0 females, this has 1, that's 2 females, 1 female, 2 females, 2 females, 3 females. Every single one of those has less than 4 female children. So we have the number of fewer than 4 would be 8. So the probability of fewer than 4 females is the number of fewer than 4 females divided by the number of our sample space, which is going to be 8 over 8, which is 1. So the probability of this event is 1. So if you think about this, the probability of having fewer than 4 females is 1. That means it's a certainty. 1, if your probability of 1, that means this is a certainty, meaning it's going to happen. If you have a probability of 0, this is an impossibility. Okay? There's no way that you can have 4 male children if you're only picking from a family of 3. But if you're asking about less than 4 female children, that's a certainty. You know that's going to happen because you're only picking from a family of 3.